Okay, good morning to grade 9 or good afternoon, depending on what time of day you woke up at. This is your Algebra Reachback week. We're doing 2 days of algebraic equations, isolation of variables, and so on and so forth. You have 8 questions, so let's get right down to it. Actually, as we go through these questions, make sure if you get anything wrong, you make a note of it because it's important that you do learn from your mistakes. Shrink that down just a little bit. It says the product of a -6. So product means multiplication. So the product of -6 and a number will be actually just treated like a coefficient. -6x divided by 1 and 2/10 means divided by 1 and 2/10. Now you could write it like that, or you could have written it as -6x divided by 1.2, or you could have written -6x divided by 1 and 2/10. Or you could have written it here as -6x divided by, sorry, not -1 and 2/10, but 1 and 2/10. I'll use it in red. 1 and 2/10. Okay? So all of these are the exact same thing, 1, 2, 3, and 4. So depending on which one you used, it is the correct answer. Your second question says the sum of 1 and 3/5. So sum this time is the mathematical word for addition. So 1 and 3/5. So 1 and 3/5, the sum. So I'm going to add that to a number. So we're going to put x for that number. And then all of this is going to be multiplied by 2/3. So all of this is going to be multiplied by 2/3. We're going to put that 2/3 into the bracket. And of course, that means we're going to use distributive property to multiply that entire term by 1 and 2/3. Okay, so that is the best expression that you could use for the sum of 1 and 3/5 and a number, all multiplied by 2/3. Now, if you didn't have that, make a note of that because that is the best way of writing it. Question 2, it says write an expression in words. So this is going to be, there's two ways to do it. You could say half, and this is the best way, half of a number decreased by 1, or half of x minus 1, or half of a number decreased by 1, either one. Or the other way is say x minus 1, or half of a number decreased by 1, divided by 2. I personally like this one better, half of x minus 1. But if you had x minus 1 divided by 2, that is also equally right. Your next one is, you can say a number multiplied by 2. So a number multiplied by 2, multiplied by 2, and decreased by 5. All multiplied by -3. That's one. So a number multiplied by 2 and decreased by 5, all multiplied by -3 is one way. Or you could say double a number and decrease it by 5, then multiplied by -3 is also an acceptable answer. So there are variations to this. There's not just one way. It's kind of a gray area. There are multiple ways to read it, but those are two ways you could have done it. Now we get into the meat and potatoes of our experiment here with algebra. We have our isolating a variable. So remember, when you are given an algebraic equation, from a grade 7 and 8 perspective, the easiest thing to do is acknowledge what the constant is and get rid of that first. So -5 is the term on the side of our variable that does not have the variable with it. So we're going to simply apply opposite operation by adding 5 to both sides. -3x equals a -4. Divide both sides by -3. Now remember, the coefficient of the negative symbol that's in the expression itself still stays with the coefficient of 3, so it's -3. And we end up with x equals 1 and 1/3, or 1.3 repeating. In our next question, we have, really it's a grade 8 question just with decimals. We're going to get rid of our constant by adding 4.5 to both sides. 1.1x equals 6.75. Then we're going to divide both sides by 1.1 to get x equals, oh, that's a 1 there. Take our calculator. 6.75 divided by 1.1 equals. So we're going to have 6.1. And notice how the 3/6 here, and then there's a 3/6 here, and there's a 3/6 there. So it's going to be x is equal to 6 decimal 1, and then 3/6 repeats. So we're going to put a bar above 3/6 because that's the part that repeats to infinity. So x is equal to 6.136 repeating. And that's your answer. Your next question, you have distributive property. Now, there are two options here. You could, and in fact, we will take both of them, and depending on which way you did it, I'll clone it here for you. Well, let's clone this and bring it over here. You could have expanded using distributive property. So instead of having, you're going to multiply both terms by -2 to give you a positive 4x minus 8 equals 5. Then you're going to get rid of the constant by adding 8 to both sides. You get 4x equals 13. Divide both sides by 4. And x will equal 3 1/4 or 3.25. Okay, and that's your answer. Now, alternatively, what you could have done here is instead of saying I have -2 groups of -2x minus 4, I'm going to divide both sides by -2. And you're going to have one group of -2x minus 4 is equal to -2.5. Then you're going to get rid of your constant by adding 4 this time. -2x equals 2.5. Is that right? Did I make a mistake somewhere? -2. Yeah, right there. Then I'm going to divide both sides by -2. Something went wrong somewhere. Where did I make a mistake? Poopy darn. I made a mistake right here. I should have had a positive 8 there, which means I would have subtracted 8 from both sides. Oopsie daisy. Let's go back here. Okay. So I should have had a plus 8 here. Oh, well. Thank God it's not live. Subtract 8 from both sides, and I'm going to get 4x equals -3. Divide both sides by 4, and x will equal -3/4 or -0.75. Hopefully I did this one right. Here, if I take 2.5 and divide it by 2, I get 1.2. Oh, did I screw up again? Oh, heavens, this is a long day if I did -3 divided by 4 divided by 4. Add. It is a long day. Look at this. It's supposed to be 1.5 here. And that is going to be x is equal to -0.75. See, even the greatest mathematical minds of our generation make mistakes. Now and again. Oopsie daisy. Note to self, don't rush. Question 6. Holy heavens to Betsy, that's one large question. Let's shrink it down a little bit here. We have variables on both sides. So let's just review for a second. If I had 2x, those are going to be x's, and -10. We use -10. And 5x and a -4. If I was to take these two x's off, in order to maintain equality, I would have to also take away 2 x's from this side. Oops, I took away 3. Okay? And essentially, that's what we're going to do here. We're going to remove 2 x's from both sides, because in doing so, that creates an algebraic zero pair. I get -10 is equal to 3x minus 4. And now we have a grade 8 question. I'm going to add 4 to both sides. I get 3x is equal to -6. Divide both sides by 3, and x will equal -2. Question 7, which is large. Now we have fractional coefficients and fractional constants, but there are two ways to do it. Now I'm going to do both ways just because I love pain and I love to do these, so we'll do it twice. The first way is to simply get rid of your constant like we normally would by adding a half to both sides. We're left with 3/4 of x is equal to the sum, I'm going to make this a little bit neater here, of 7/8 and 1/2. Now, of course, when you add fractions together, you need a common denominator. And we're going to use this, and we're going to get 11/8. And I'm just going to keep it an improper fraction. I'm not going to change it to 1 3/8, because what I'm going to do next is, in order to get rid of a multiplier, I'm going to use the opposite operation, which is dividing by 3/4. That gets rid of the multiply by 3/4. And this side, I'm also going to divide by 3/4. So x is going to equal. Of course, we learned that the easiest way to divide fractions is to change the multiplication by the reciprocal. And a lot of us like to cross-reduce, and I'm just going to cross-reduce here. If you didn't cross-reduce, that's okay, because you're still going to get the same answer. You get 11 over 6, right, as your final answer, or 1 and 5/6 as a final answer. Okay, and that's if you just used constant first, coefficient second, opposite operation. But another way you could have done it says, okay, the first thing I'm going to do is change that to 3x over 4, because of course 3/4 multiplied by x, or x over 1, multiply the numerators, I get 3x, multiply the denominators, I get 4. So another way to write 3/4 of x is really 3x over 4. And what I'm going to do here is I'm going to multiply both sides by 8. Okay? So I'm going to multiply this side by 8, I'm going to multiply this side by 8. All right? Now I'll start with this side. 7/8 times 8. I'm just going to cross-reduce. It's going to leave with 7. And over here, if I think of 8 as being 8 over 1, multiplied by, I'm going to clean this up a little bit. It's a little messy. So I'm going to multiply 3x over 4 by 8. And I'm going to multiply, because I'm using distributive property, I'm going to multiply -1/2 by 8 as well. So when I do so, I'll use a blue pen here. Cross reduce, I get 2 over 1. I get 2 multiplied by 3x, which is 6x. Cross reduce, I get 4 over 1, which is -4. So by multiplying both sides by 8, I end up getting rid of all fractions, and I end up with this expression, or this equation, excuse me, 6x minus 4 equals 7. Once I get to there, I'm going to add 4 to get rid of the constant. I get 6x equals 11. Divide both sides by 6. And I get the same answer. Okay? So whichever pathway you chose, I probably would have done this way. But if you did it the other way, there's no reason why you couldn't. Just a little bit more work. But it always ends up working out all right in the end. And finally, your last question, which was, I think, your hardest one, but not too hard. It wasn't mind-bendingly difficult. Like the other one, you could have multiplied both sides by 20 if you choose, or I am going to just use, I'm going to add 13/20 to both sides. That's going to get rid of this, and add 13/20. Okay, so I have 1/4 of x minus 5, or x minus 5 divided by 4. Either way you want to say it. I would rather you say 1/4 of x minus 5, because it's a better way to get an idea of what it means. And over here, I have to add these together. Now you can just take your whole number and put that aside if you want. And then add 9/10 and 13/20. So that is going to be 18/20 plus 13/20, which is 28/31/20, which is 1 and 11/20. Plus this 1 that we had here is going to make that a 2. So that's going to equal 2 and 11/20. Or I should have kept it as 51/20. I shouldn't have changed it. We're going to keep it as an improper fraction because we're not done working it out. So rather than change it to mixed, which I shouldn't have done, it's 51/20. Now I'm going to multiply both sides by 4. I'm going to multiply this side by 4. Now 4, of course, is the same thing as 4 over 1. So I get x minus 5 is equal to the product of these. Cross reduce. I get 51 over 5. Now, because I'm going to add 5 to both sides, I think I'm going to take time to change this 51 over 5 to 10 and 1/5. Because right now, when I add 5 to both sides, x is going to equal 15 and 1/5, right? That makes it a lot easier at that last stage. So that's your final answer, 15 and 1/5. I think it is, unless I made a mistake. And if I made a mistake, email me tomorrow and let me know, and you can yell at me. You can call me a doofus if you want. I'll let you call me a doofus one time if I made a mistake. Thank you guys for participating. I really appreciate it. Make sure you make notes of any mistakes you did make, and tomorrow there will be another Reachback to Algebra, and you can use this as a guide if you did make mistakes, and if not, just keep practicing, just like basketball. The more free throws you take, the better you're going to be as a basketball player. So thanks very much. We'll see you guys tomorrow. Make sure you wash your hands, maintain social distancing, and as always, don't let your boomer parents drive you crazy.